Next speaker is Ms. Diana Khaydukova, head of the Digital Photogrammetry Department of Uralgeoinform. She will speak about technological capabilities of PHOTOMOD 6.0, practical implementation in the cartographic production.
I'd like to thank Rakurs for a conference professionally organized and for a chance for us practitioners to get close and familiar with latest technologies. I represent a subsidiary of Roscartografia in Urals. In 2015, the department that I represent has 9 people of staff. Our areas of expertise include field surveys, mapping, photogrammetry, and various mapping-related activities. All implementers have great experience in the field of stereo representation. As you can see, our team is small, so a delivery of a service requires use of every person available. We have been in the market for 7 years. We started with PHOTOMOD version 4. We are still using it. So when the latest version 6.0 came out, we immediately put it into operation. And we planned to use this for satellite imagery mostly. This slide lists modules used by Uralgeoinform. Since optimal use of RAM is one of the key advantages of PHOTOMOD 6, we purchased new workstations on which 64-bit Windows system was installed. The slide shows how our system is set up. As you can see, for distributed processing, we use 9 clients and 12 streams or flows. Obviously, server is a hub which receives and processes all the information. This is an important factor, as we all know. And the network was used, we used the available network and would not invest in upgrades. The only thing we improved or upgraded was the amount of storage. Where we stored all initial data. One of the largest products in 2015 was a project launched by Uralgeoinform in November 2014. We needed to create orthophoto plan based on satellite imagery for around 675,000 square kilometers. These images mostly came and were captured by Chinese satellites. The resultant volume of digital orthophoto plans was 3,000 stock sheets. The workflow that we intended to use was a standard one. This includes loading of satellite data, DEM generation, ortho transformation, and other stages. As you can see on this diagram, the adjustment module and creation of digital DEMs limits the number of performers. As you can see, there is only one adjustment module we have for space images, and since there are no investments made, we decided to do a technological experiment where we plan to work until February 2015 using two people. Additionally, we pursued another objective. We wanted to identify points of optimization of the traditional scheme, including technological stages, and also to identify some risk areas. In fact, we're talking about two people working on two computers. The other workstations were used routinely. The work plan was intended for 3 months. The first batch was supposed to come out 4 weeks later. This is how we distributed roles. The first expert collected data and adjusted data. The second expert assisted him or her by doing data collection, data adjustment, DM generation, and ortho transformation. So all the processes were done both consecutively and simultaneously. If there was any delay by more than 1 week, we would have ended the experiment. So we put together a work schedule, and at each stage we evaluated setbacks or lag time. If that lag time was too much, we had to stop the process, purchase new modules, and engage more people. So what are the benefits and disadvantages of working in this fashion? As you can see from this diagram, to downlink data, we needed to use automatic systems. And the data comes in streams, in several shipments or batches. So when you use distributed method, the manual interference is limited to 0. Some of the satellite images could not be downlinked because PHOTOMOD did not read RPC coefficients. But we fixed this problem quickly, and then the process started to work in a routine method. As for adjustment, manual labor was used. We do it manually because images came in batches, and there were images that had no overlap at all. We called them holes. Some of the images didn't have overlap at all. So there were blocks of images that could not be connected to each other. So we divided the volume of work by 14 blocks, and adjustment and matching was done in parallel. In PHOTOMOD 6 version, it was easy to edit resultant points. And it was a lot better to do editing together with adjustment. We had only one adjustment module available, so we could not distribute the adjustment process on 2 machines. This has led to a relatively critical delay in operation, but since information flew consecutively, we did not discontinue the process. The adjustment process The good thing is that some of the points well, anyway, we had to limit the use. No, we used open sources to identify some points. Since our blocks were relatively large, we assumed to rely on BC coefficients and to use as few GCPs as possible. We found that we had to set a redundant number of points to meet the required range. When it comes to DM, it's 90% automatic and 10% manual. Why? Because initial information came in digitally. Ortho transformation is 100% automatic process and 28 streams that could address the tasks required. Building cut lines. PHOTOMOD allows us to build the process fully automatically using distributed mode. We did an experiment and built cut lines automatically, started to control them, and then they did some cut lines manually, and it turned out that time-wise it was basically the same. Since we have very good experts, we decided that we will not spend time on automatic cut line creation, and we did it manually, which amounted to 90% of manual time. As for control and building ready product, the final stage, well, the final product was to be delivered in RSV format. At that moment, PHOTOMOD didn't have this capability. We had to create TIFFs. Then using Panorama, we created SVs. But since we have a fairly powerful computer, we were not limited in time. So this is the situation with workflow comparison, automatic, assumed automation, and what happened actually. As a result of this experiment, we made conclusions that we definitely need to upgrade our technological process to reduce overheads. We did not find any points for optimization because the classical technology was totally optimized and tested by time. And the main condition, the main requirement for ending the experiment successfully and in time is timely delivery of good quality materials. In order to use PHOTOMOD automation effectively in the future, we need to purchase the necessary number of adjustment modules, multiple to the number of operators, and the rest can be handled by our professional hands. The next slide is an example of an interesting project which we did using PHOTOMODs. The customer needed to do an analysis of geological information to select a strategy for gas carrying deposit. But 500,000 points located throughout geological profiles did not have absolute values of elevation. We had already created 1 to 25,000 orthophoto plan. We had satellite imagery to rely on and digital surface model. Using PHOTOMOD, we specified added accuracy to the model, bringing it to 1.7 meters, and out of 570 points, we were able to control our digital elevation model and identified the third coordinate for missing 400 points. This was done in one workday. Which would require the entire field season had we not used the PHOTOMOD, and the rate of return here was 28%. Another useful and teachable project was Ultracom based project, where we took into account all conclusions and upgraded our software. Now we have 1 gigabyte dedicated network. Capabilities of our computers went up. We have 49 streams for 8 computers. It's very modern. Processors i7, i5. I hope we will have enough storage to calculate the digital elevation model, for which we have great expectations. I think we will do this project together with Rakros. Okay, that's it. Thank you very much. Thank you very much. I suggest that